Okay, I'm going to go through first an example, and the directions will say solve the system of equations by using matrix equations. Okay, they're going to give you, we're going to do two equations, two unknowns. Say I give you the equation 2x plus 3y equals a negative 17, and x minus y equals 4. Okay, when you use matrix equations, what you do is it's very similar to matrices, but it's not. You take you want to make sure the x's and the y's are lined up, and you take just the coefficients, the 2 and the 3 and the 1 and the negative 1. Take the coefficients and make that into a matrix, and then a matrix xy. X is the first row, y is the second row. And then put your constants, negative 17's first row. And if you multiply this out, if you took time to multiply this out, you'd say this would be 2x, come across here, plus 3y equals negative 17. And you go x minus y equals 4. So it's just a different way to write the two equations to unknowns. Okay? Now, the whole idea is to solve this matrix equation and get the x and y by itself. Okay? Forget this equation for a minute. If I did this equation, okay, how would you solve that? You divide by 8. Only problem in matrices, I didn't show you anything with division. So division is out. Now how would you solve it? Multiply by, 1/8, like its multiplicative inverse. Okay? You would multiply by either 1/8 or 8 to the negative 1 power on both sides. Okay, now that we did go through yesterday, so we have to get the multiplicative inverse of this matrix. Okay, now, before we do that, let's talk about this a minute. If this was like matrix A, you have matrix A times, and I'm going to call this matrix, this one matrix M, and I'm going to call this matrix B. Okay, and I want to get this by itself. So what you have to do is you have to multiply by the inverse of matrix A inverse. Okay, but what we did yesterday, I showed you that multiplying by commutative property of inverses is not. I'm not saying that. You can't do AB and BA. Okay, they're not the same answer. Okay, that multiplication of 2 by 2 matrices is not commutative. That's better. Okay, so if they multiply by A inverse on the left, that means we have to force A inverse in front here. Okay, you can't put A inverse on the right over here. That does not work. Okay, this is called hitting it on the left, so you have to hit this one on the left. Okay, and then this will go to the identity, and the identity times M is just M. So really what you're figuring is A inverse times B. Okay? Okay, so first thing you got to do is figure the multiplicative inverse of this. I showed you the shortcut. First thing you do, if this is A, you can do, now you can start writing. If this is A, let's find its inverse. You have to do the determinant first. Remember, it's outside 1 over the determinant. So you multiply down the diagonal to the right, so that'd be negative 2. And you subtract the product coming back up, 3. So I end up with the determinant is negative 5. Okay? So it's 1 over the determinant. And I would leave the fraction out front. Leave that scalar out front. Okay? The 2 down the diagonal to the right, change places. So this would go negative 1 and 2. Whatever this sign is, whatever that sign is, change it. So that's going to be -3, and whatever this sign is, change it. They don't change signs with each other. Okay? So that is my A inverse. You agree with that? Okay, so we're going to do this, come back up now and solve this. So we put that out front. Now, here's where you have to be careful. You got to force this inverse, you got to force this in front over here. You have to hit it on the left. And leave that scalar out front. And then it's times the -17.4. Okay? Now, if we did this right, this whole thing goes to, if I multiplied that out, I would multiply it this way. I would multiply the -1, -3 times this. I'd multiply this, I'd multiply all that out, and then I would take it times that scalar. Okay? When you do that, you should end up with the identity 1, 0, 0, 1 times the xy. Okay, leave this scalar out front. Okay, and now let's multiply. Okay, so now you got to multiply, and do this with me. -1 times -17, 17, and then -3 times 4, -12. 17 and a -12. Positive or negative? +5. Okay? And then take this row times this, so -1 times the -17. 17 and 2 times 4, 8, and 17 and 8, 25. Now you multiply that scalar. And when you multiply this, you take this times this and this times this. It's just going to go to xy. Okay, and a -1/5 times 5 would be a -1, and a -1/5 times 25 would be a -5. Remember, it's like this, -1/5 times 5. That's like 5 over 1. You can reduce it, or you can multiply across on top, multiply across on the bottom. Okay? Okay, so the whole trick to that, and if I turn this around, is if I turn this around and let's say I had a matrix N, and I had that times A, and I want to solve for N, then I would have to hit this one on the right with its inverse. If I hit that one on the right, then I would have to hit this one on the right. Okay? Most of the time it's going to be like our example. Okay? Okay, so now that will help you on 11 and 12. Okay? So you can go back and try to work those. Follow that example. Okay? Plus the author gives you some examples too. Okay, the next thing I want to go through is what they call Cramer'S rule. They will ask you to solve using Cramer'S rule. We're still solving two equations to unknowns. Remember, we've done it by graphing, substitution, elimination, matrices. Now we've done it by matrix equations. Now we're going to do it by Cramer'S rule, or that's also by determinants. To be honest, this is one of my favorite methods. Okay, if I take the 2x, same equation, 2x plus 3y equals -17, and x minus y equals 4. We want to solve it by what they call Cramer'S rule. For Cramer'S rule, if I solve for x, we're going to set up two determinants, one in the numerator that's a 2 by 2 and one in the denominator that's a 2 by 2. The one in the denominator is always just the coefficients, 2, 3, 1, -1. So that goes down in the denominator. 2, 3, and 1, negative 1. It's just the coefficients of the x and the y. Okay? If you're solving for the x's, everybody look up here for a minute. If you're solving for the x's, you take the two constant terms and you replace them in here. Okay, so it's going to go negative 17, 4. And then keep the coefficients of the y, 3, negative 1. Okay? Now do the 2 by 2 determinants. You multiply down the diagonal to the right. So that'd be 17. You subtract the product coming back up. So subtract 12. Multiply down the diagonal to the right would be negative 2. And subtract the product coming back up would be 3. So you'd have 5 over a negative 5, which would be negative 1. And that should check. Okay? Now, to solve for the y, we already know what the bottom is. You don't have to figure it again. The denominator was negative 5. To solve for the y, if we're solving for the y terms, you take these two constants and put them in place of the y coefficients. So we're going to have 2, 1, and negative 17, 4. Okay, with what I'm doing? You follow that? Okay, multiply down the diagonal to the right and subtract the product coming back up. So it'd be minus a negative 17. So that'd give us 25 over a negative 5 would be a negative 5. And our ordered pair, our answer then would be negative 1, negative 5. Remember, it's always alphabetical on your ordered pair. And you should know before I check your test whether or not your answer is right. That ordered pair needs to work back in both these. If it doesn't, you know you've got an error. So go back and check your arithmetic. Yep. From right here. The denominator is going to be the same on both of them. So you don't have to work it twice. Just work it once. Yep. Okay? Okay, so that's solving by what they call Cramer'S rule. Okay, now let's go through. Yesterday I did a 3 by 3 determinant by expansion of minors. Okay, today I'm going to cover a couple other methods. Okay, one is what they call the lattice method. And all of this is going to be on iTunes U, so if you miss something, and I'm going through this pretty fast, so if you miss something, go back through it again. Some of you may need to go back through it more than once. This is called the lattice method for figuring 3 by 3 determinants. Okay, so I'm going to give you a 3 by 3. If you just listen, you'll get it. First row across, 8, 9, 3. Second row across is 3, 5, 7. I think this is one we worked yesterday. Third row across is negative 1, 2, 4. Okay, take the first, and you may want to highlight them. Take the first two columns, and you're going to repeat that column on the outside. Okay, and take the next column, and you're going to repeat that. Now, one thing about this is you kind of want to keep things lined up. Okay, repeat that on the outside. Okay, you may want to highlight those or circle them. Okay. Now, the lattice method, you multiply down the diagonal to the right. Did you do it last year, the lattice method? Okay, good. So it's familiar. Okay, and you can use your calculators on this for the arithmetic part. When you multiply that down, you're going to get 40 times 4 would be 160. Multiply down the diagonal to the right, and that would be, what, a negative 63. You're going to add the products going down to the right. And multiply 3 times 2 would be 18, and add that. Okay, then you're going to subtract the products coming back up. Okay, so you're going to multiply these, and that would be negative 15, and subtract the negative 15. Okay, then you're going to multiply 2 times 7 would be 14, times 8, and it's going to be 112, and subtract it. So subtract 112. And then you'd have 12 times 9, 108, and subtract it. Okay, then you have to do the arithmetic, and just go left to right. And on this one, this ends up to be the same as what we got yesterday. That is a negative 90 when you do that. Okay, it's a lot of mental arithmetic and working with positive and negative numbers. Okay, so that's the lattice method. You repeat, and you may want to either call attention to it. You repeat the first 2 columns on the outside. You multiply down the diagonals to the right, and you're going to add those products and subtract the products coming back up. Okay? I'm going to give you another method for 3 by 3 determinants. This one was actually just, oh gosh, in the last 5 years. And this was a high school senior that discovered this, and he got credit for it in the National Council of Teachers of Math magazine. So they named it after him. Okay, this is the Comer'S method for figuring 3 by 3 determinants. Okay, and this one's a different one. First row across is 2, 3, 4. Second row across is 6, 5, 7. Third row across is 1, 2, 8. If this number in the middle is 0, his method will not work. Okay? Okay, what you do on Comer'S method is you split this up. Everybody look up here for a minute. You split this up into 4 2 by 2s. This 2 by 2, this 2 by 2, this 2 by 2, and this 2 by 2. Okay, you do that first. Okay, so split it up into the 2 by 2, 2, 3, 6, 5. Okay, and then 3, 4, 5, 7. Now, I would keep these in order, okay, and then 6, 5, 1, 2, and then 5, 7, 2, 8. Okay? You figure each one of those 2 by 2s and take those 4 answers and make a new 2 by 2. Okay, so multiply down the diagonal to the right, so that'd be 10, and subtract the product coming back up, and you get a negative 8. Multiply down the diagonal to the right would be 21, and subtract the product coming back up, and you get 1. Multiply down the diagonal to the right would be 12, and subtract 5 would be 7. Multiply down would be 40, and subtract coming back up would be 14, and I get a negative, or 26, sorry, 26. Okay? Now, you use those 4 answers to make a new, and they have to be in order. Okay? So, like, this answer is the first one up here. This answer is the second one in the first row. So it's going to go negative 8, 1, 7, 26. Okay? Then multiply down the diagonal to the right. Okay, and I get a negative, that's a negative 20, no, 208, sorry. And subtract coming back up, and you get a negative 215. Okay? Now, that's not the answer. It all comes back to this number in the middle. Then you divide by that number in the middle. divide by 5. The final answer is a negative 43. Okay? So when you do that, you just have to be organized when you do your 2 by 2s. Keep them in the right order. Get your answers. Make a new 2 by 2 and then divide by that middle number. If this middle number is 0, you can't divide by 0, so it would not work. Okay? Okay, now let's do it on the calculator. I've shown you some ways. Let's do it on the calculator. Okay, first thing we need to probably take and delete some of the matrices from last year if we have any in here. Right above the plus sign is min. Do second function min. Okay, should get to this menu. Okay, now you want to be very careful when you do deleting your memory stuff. So go down to memory management, delete number 2. Okay, then you should see matrices come up. Everybody there? Okay, go down to matrices, number 5. Now, if you are a gamer, if you download games to your calculator, you want to be very careful about which matrices you delete. Because a lot of times there are maze games that they do it by matrices. And this just tells me how much memory it's taken up. So if you have any in there, delete them. Here's the delete key up here on the top row. Just delete. Okay? If you don't have any, you're okay. Do second function, quit, takes you back to the home screen right here. Second function and quit takes you back to the home screen. Okay? If you look right above the x to the negative 1 key on the left, it says matrix. Find it. Okay, so do second function matrix. To get any matrices in, you have to right arrow over to edit. Okay, so go over to edit. Okay? And press enter. Okay, and we're going to do, let's do this one. Okay, it's a 3 by 3, so you got to put in 3 by 3. Okay? You should see a bunch of zeros come up. Okay, now I use both hands. I use this hand on my enter key and this hand to type in the number. It's quicker. Okay, so, and these are going to go across. So put in 2, 3, 4. Then put in 6, 5, 7. 1, 2, 8. Okay? We got it in? Go back to the home screen. Okay, do second function quit. Okay? Then do second function matrix. Move right above the x to the negative 1 key. Right arrow over to math. Ooh, determinant. First one, determinant. Press enter. Now you have to tell the calculator which matrix you put it in. So do second function matrix. And there's matrix A. Press enter. That was a lot quicker than all the work we did. Okay? Okay? Okay, now, you have to make enough notes that you remember what you did, say, a year from now, 2 years from now, 5 years from now. You're going in to take the graduate record entrance exam to get your master's. Okay? What did we do? Okay, so I always do enough notes. So I did like second function. That's a key. If it's a key, I circle it. I did second function matrix. And that was actually above the x to the negative 1 key. So, okay, and then we did right arrow over to edit. To get anything in, you have to put it, you have to get to edit. Okay, then we had to type in the dimensions. It was a 3 by 3. Okay, then we actually did second function quit to get back to the home screen. Then we did second function matrix. Then we did right arrow over to math. Then we did determinant. We pressed enter. And then we had to do second function matrix again. And then we had to pick matrix A. And then we had to press enter again. So you got to make enough notes. And if you have a graphing calculator or you have an iPad, you can look it up on the iPad too. They'll tell you the steps. Okay. Okay. You can also multiply matrices on the calculator, and everything we're doing on the calculator, you have to be able to do by hand, and then you have to be able to do it on the calculator. Okay, let's do a multiplicative inverse, and I may run out of time, so I will probably try to record the rest of it and put it on iTunes. Okay, let's say I give you a matrix. I'm going to give you matrix B. 3, -4, and 9, 12. And I want to figure the multiplicative inverse like we did yesterday. Okay? So, let's do it on the calculator. Second function matrix. To get anything in, you have to right arrow over to edit, and then you got to go down to matrix B. You got to go to edit first. And our matrix B is a 2 by 2. Okay, now get the matrix in. 3, -4, 9, 12. Go back to the home screen, second function quit. Okay, and pick up matrix B. It's going to look like this. So pick up matrix B, second function matrix, go down and pick up B. And then use your x to the -1 key, your reciprocal key or inverse key, multiplicative inverse. Okay, now it shows up in decimals. Go back to fractions. So go to the math key, and this says go back to fractions. Okay, and that is my inverse. Multiplicative inverse is 1/6, 1/18, -1/8, and 1/24. Okay? This is that x to the -1 key. You can multiply matrices on the calculator. You put them in, you just multiply them. You don't even need the time sign in there. Okay? Okay, I think that's as much as I'm going to get through today. Okay?